Young is going to time.
I'll stand up at 7 minutes.
Yes. Yes. So, my group from Williams College, which included 8 of our undergraduates and a variety of other colleagues and alumni, were in Salem, Oregon, where we were treated to exceptionally clear skies. And we obtained all kinds of imaging. The names of our observing group, including the students and some colleagues from various countries, is at the bottom, and one of our combination images is there from some dozens of the individual images to bring out the features. The abstract you can all read, and it's basically to show you a variety of the things that we have been doing. I do want to mention the credits, as we have at the bottom. We had an original grant from the Committee for Research and Exploration of the National Geographic Society, and then we got a larger grant from the Solar Terrestrial Program of the Aerospace and Atmospheric and Geospace Sciences Division of the National Science Foundation, and then we were able to bring in more people with some NASA space grant and some other funds. We have mastered the techniques of making high-resolution composite images. Some of you may be familiar with the work of Miloslav Druckmiller, a computer scientist with whom we worked in the past, and he is now doing only his own work, and which I guess has a relation with Shadia, who you hear from next. And we have been working with some people, including Roman Venur in Slovakia, with this very high-resolution imaging. And in particular, you've heard mention of the polar plumes. The last few eclipses, of course, there's a sunspot cycle that I don't think has been mentioned in this session so far. We're at the low point, as most of you know, in the sunspot cycles, where the plumes have become visible again. So we had a paper about the 2006 and 2008 eclipses with velocities and plumes, but we just haven't been able to see the plumes for the last few eclipses because of the high latitude streamers. But now we can study them. Here's a list of our collaborators. Ron Dantowitz has been important to various aspects. Vojtech Rusin from Slovakia, John Siridakis and Aris from Greece. Dan Seaton, an alumnus who now is working with the new solar telescope on the GO-16 spacecraft, and some of our other colleagues there. Here is our student group in Salem, Oregon, in the picture, and we were on the campus of Willamette University, so we had good facilities, electricity, computers, etc. Through my post as chair of the working group on eclipses of the International Astronomical Union, we had a lot of collaboration and helping people come to an eclipse in America from the same countries that have helped us in the past going to eclipses in their countries. So here's the Chinese team that was with us, and the Japanese team that was with us, and the Williams College team at the top. And we were very fortunate to have the exceptionally clear circumstances that a lot, but not all of the country had. So here's just a composite there. And I was glad that one of our images we put together with an internal image from Soho and later replaced with SUVI on GO-16, and then you can see the solar minimum type corona with only a few equatorial streamers, and the black and white is filling in with our eclipse to give the complete view of the sun that is available only on the days of eclipses. And here is our highest contrast resolution. You can see the plumes extend out quite a way. We do have measurements from 10 years ago of those plumes from 3 different locations scattered every 20 minutes or so. So we didn't need continuous observations to measure some velocities, and we'll measure what velocities we can, comparing things from across the country. And there were some features that really pointed out here that really show the three-dimensional structure. This is really a porcupine that we're looking at in the solar corona. And so we're projecting the three-dimensional structure back on the plane of the sky, and then in turn on the image. And we're working in particular with Zoran Mikic, John Linker of Predictive Science, have submitted a paper on comparing the predictions that they make on the basis of the photospheric magnetic field in the weeks before the eclipse and our observations. We did have some colleagues in Carbondale, and we can compare some of the detailed features already between Salem on the left and Carbondale on the right, and we can see a whipping of a fine feature there that we bring out in this resolution. And the Carbondale people, Tom Economou, University of Chicago space scientist, has enhanced automatically the edges of the features, and this is another technique that we can continue with for measuring velocities in particular. The GOES 16 was launched in November by NOAA, and it does carry a new solar telescope on it, solar ultraviolet imager, SUVI, that our alumnus Dan Seaton is working on the solar aspects of, and this comes from the idea many years ago now that the solar panels of spacecraft point to the sun, even if the spacecraft itself is mainly looking down at the Earth or somewhere else. So this series of 3 plus a spare GOES spacecraft in this series is supposed to give us a continuity in the solar ultraviolet for another 20 years. And in fact, it has a bigger field of view than other ultraviolet images, so we can see some features a little further out. You saw there the eclipse going across. Here is one of the SUVI images with very nice high resolution, and you can see the coronal holes at the poles, and you can see the plumes coming near there, and you see the continuity. Here's a higher contrast image of coming out, and the SUVI does continue outside the limb of the sun for a way, so we can have continuity there at the very lowest corona as the moon moves across and covers a part of the sun. We work with Wendy Carlos on lower contrast reduction that gives more of the way the eye sees it, and in the draft paper that we've submitted with Linker and Mikic, and also Miloslav Druckmuller, we have both kinds of reproduction with different contrast. There was a wonderful prominence here near one of the diamond rings that I don't have time to talk about, but there are a lot of motions in prominence. Of course, prominences can be studied in other ways. We had 3 spectrographs with us. These are some data from Aris Vulgaris, from our Greek colleagues with National Geographic support. And here you see the iron 10 and iron 14 lines. And we've been monitoring those over the last sunspot cycle, and we can actually see the temperature flip from, the ratio flip of the intensity of those as a changing temperature over the sunspot cycle. And we continue to compare those data. We have higher resolution spectra and imaging in the different spectral lines. This is an article from my August Scientific American article showing some coronal loops and some ideas in the kinds of waves and the periods of the waves that we may have, and we're using these high speed observations to try to determine among methods of coronal heating. Ned Ladd from Bucknell, another alumnus of ours, has a poster with his student Peyton. I forget Peyton's last name at the moment. That you can see posted, but here are our coronal red line and coronal green line, iron 10 and iron 14 for forbidden lines, and just covering a portion of the limb of the sun that we're examining for at sub-second resolution. And there are different predictions from nanoflares and from surface alpha-N waves and from body alpha-N waves. We do have imaging in the coronal red line and the coronal green line of the whole sun, and if you subtract those, you can actually see the difference in the temperature structure of the sun. We worked with an atmospheric physicist, Marcos Peñalosa Murillo, in measuring the irradiance at the same time as the temperature, and which you can actually see the irradiance dip here, and you can see the temperature dip and the pressure change as the eclipse goes by, and we're analyzing those as we have for several past eclipses as far back as 2001, and you can see the wind drop too, as in the measuring that we did. And the final comments, we were part of NOVA on PBS, so that aired the night of the eclipse. They had it in the can except for 10 minutes on the final night, and it aired it a couple of days later. And last week I heard from 3 people in Australia when it was shown there. And I'm just going to end with a brief movie of just the diamond ring coming to see the shadow come. So I was glad to see at the beginning so many of you had seen the glory of the total eclipse, though I guess I was disappointed that there weren't more people here who we could inveigle to go to the next total eclipse. So I give each of you the assignment, take 5 friends to the eclipse in 2024 who otherwise wouldn't go. Here's another composite image, and we probably have time for a question. I like this XKCD also, and we do have a website at totalsolareclipse.org, which has a lot of the images you've seen and other things about past eclipse expeditions and current ones. Is there a question? Yes.
Could you say just a little bit about how you measure the velocity of the plumes?
Well, yes, we can measure precisely on high-resolution images, on these composite images, just where they are. We can subtract the images, and we can see the differences.
There are features on the plumes that you measure.
Yes, you can see the extent of the plumes. I can give you a reference to a paper we had, in particular, the plume velocities in the Astrophysical Journal in 2008, and that's also linked through this website there. Okay, thank you very much. And now.